Good afternoon. Hopefully you enjoyed all a very good lunch. And in order to keep you awake, we have a very interesting session. So welcome at one of the first ICAS Awards on Innovation in Aeronautics. My name is Michael Peters. I'm the General Director of the Netherlands Aerospace Center in Amsterdam. And the ICAS Award on Innovation in Aeronautics, the recipient is the AGILE Project Consortium. Now, the AGILE project is a research program, it's a research project. It's funded under the European Horizon 2020 program with 19 partner organizations and more than 110 engineers and scientists involved. And the full title is, and I have to read that, Aircraft Third Generation MDO for Collaboration of Heterogeneous Teams of Experts. And the award is given for achievements in the field of collaboration. And the proof of that is, of course, that we have 19 partner organizations working together with more than 100 individuals involved. On behalf of the project consortium, the project will be introduced by only 2 of the 110 engineers involved, by 2 speakers. And first is Bjorn Nagel. And Bjorn has a diploma of aeronautical engineering from 2013 from the Technical University of Braunschweig in Germany. And since 1998, he is working for the TLAR, the German Aerospace Center. And since 2017, he is the founding director of the new TLAR Institute of System Architecture in Aeronautics in Hamburg. The second to introduce here, the second speaker, is Pier Davide Chiampa. Hopefully I pronounce your name correctly. He has a BSc from La Spezia in Roma, and he has a Master of Science of Aeronautical Engineering in the TU in Delft, the Technische Universiteit in Delft. Easy for me to pronounce that, and he awarded that in 2008. And since 2008, he left the Netherlands and went to work for TLAR in Germany. He has the lead of the MDO team, and he is working at the Institute of System Architecture in Aeronautics in Hamburg again. May I ask you to stand first, Bjorn Nagel, and after that, Pier Davide. Thank you very much.
Many thanks for the very kind introduction. First of all, it's a great honor to stand here and to present the AGILE project for you, Pier Davide and me. Of course, we're doing this on behalf of the entire project team, which won this award together. It's not only us. But we try to give you an overview what is actually AGILE, which stands for this very long name of this project. Well, we received this award for innovation. Innovation in aeronautics, you all know this, is it's a challenge, because aeronautics is very complex. It's a linked systems, different elements. We have the technologies, we have different drivers for the aeronautics systems, the operational drivers, and somehow everything is linked via the vehicle in the middle. And this already is the biggest challenge we have, because all these elements are linked. So aeronautics is a system of systems, and when we want to introduce innovation to the system, we cannot touch only one of the fields, we have to consider everything together. And this is in particular a challenge when we really want to go forward to innovative solutions which are far more in the future. This is the reason why in aeronautics from the beginning we've been using multidisciplinary design optimization to design vehicles and to bring in our solutions. So, in MDO, we say there are multiple generations we can distinguish. The first generation MDO came in the 80s when computers became available, so we had first disciplinary codes on one computer and tried to somehow do something with the computers which were available. Very early we thought we want to go for higher fidelity codes which really resolve all the disciplinary aspects we want to see. So, yeah, we're driving for novel solutions, and now, say, somewhere around 2000, we had something like the second generation MDO. So when we really made use of the computational power we have, we distributed the loads across multiple computers. Actually, there's a lot of software available today, or has been for many years now, where you can easily do multidisciplinary optimization and cover disciplinary analysis goes together. But what is a bit surprising is that actually, though we have the software and we have the hardware, we do not see applications, at least not to that extent that you would expect. So let's go back. Why do we only see these very narrow applications, usually 2 or 3 disciplines? From a software point of view, there is much more we could do. And we came to the conclusion that this second generation MDO, with all its hardware and software we have available, is not enough. And that what is missing is actually the competence to operate the system. Because we have all these different tools, and the tool alone does not help. So, say the third generation MDO is a combination of the hardware, software, and with the competences of the people to operate this. And really this is the innovative point in the AGILE project. So please let me show you one picture to illustrate this. What's the difference? So we're not talking about tools anymore, we're talking about skills. And this picture should illustrate you what's different. You see there a tool, a very simple one, and in the background a person with capability of the skill. In MDO, we've been focusing on combining tools, and we are quite far with this. We can combine multiple tools, but we are lacking is the capability how to properly make use of the competencies we have at Consortium and to make use of all these tools. Because also in engineering, it's like in medicine. Everybody of you can easily get this kind of tool, but you should not use it unless you have the competence to do it. And as obvious as it is with this tool, it's the same with engineering tools. You need to know what you're doing, and if you want to combine tools, you think how can you combine the people behind. This brings me back to the opening of this ICAS conference, of the very nice introduction of Daniel Moslover from Embraer, who said the new goal is knowledge and the new mining tools are collaboration. So this is exactly what we're looking at. How can we do better collaboration? Because we know collaboration is a bottleneck in MDO, but how can we approach this in a scientific way and make reuse of this knowledge to enroll this better? This is the starting point for the AGILE project. To introduce this, as was said, we have 90 partners from Europe on this project, plus Russia, plus Canada and Switzerland. I don't read all these names because so many. We'll come back to the partners, and when we receive the award, we will invite all the partners who are here in the room to come up and join us here. Only very brief, we wanted to have 90 partners to really be able to see how to collaborate with different kinds of partners. It's very interesting to have people from different nationalities, from different types of organizations, from industry, from research, from academia. And so this kind of a large-scale, or relatively large-scale research project was necessary, inevitable, to really do research on the topic of collaboration. And now, when we introduce you to the technical contents, I want to hand over to my colleague Filho, who is the project coordinator of AGILE, and he's probably the one who did most for that project and holds this award most. So please,
Great. Thank you, Georg. And it's kind of honor for me to be on behalf of the Consortium, the AGILE Consortium, to present you a brief overview of technical activities behind this project. As Georg mentioned, behind this project, the core is collaborations. And if indeed collaboration is a tool mining for knowledge, I'd like to say that the next steps is how to integrate knowledge into products. And what is the speed to do that? So in other words, in innovations, an important metric is the speed for innovations. And if you look at the aeronautical products, we typically have a situation of collaborations. So aircraft are developed concurrently by different companies, organizations, suppliers. And if we look at the times of innovations, nowadays, for large-scale aircraft, we have a little bit less than 10 years development times, from requirements until the first flights. And there are some reasons for that, of course. Indeed, the number of parts, sub-processes, which need to be integrated into a single product. Second point is that the distribution of knowledge, heterogeneous skills between different organizations and partners, different way of working, different models, standards, all need to come together into a complex product. Another last point that says the level of integrations in innovations. So there is a demand for more technologies, more functionalities integrated into a single system. And these have complexities. And eventually it takes 10 years to develop a conventional aircraft. The question is how long it will take to develop an unconventional solutions. So we start to ask ourselves within the consortium the main questions, which is, can we accelerate the development times of aircraft products via the next generation MDO, by a new generation of collaborations in design and optimization processes. Now we'll go a little bit more technical. If you're involved in designing and optimization processes of any kind of products, in this case for aircraft, you typically are in a situation to have a list of competencies, like you mentioned before, so a portfolio of capabilities distributed in your companies, in a consortium, in this case in the AGILE project. And on the other side, we have the implementations into systems which would help to design and optimize the products. Now, before coming to the assembly and the deployment of the systems, there are different challenges here. One of the challenges, how should we implement our system? What is the formulation of our design program? Or in other words, what is the strategies that we would like to deploy to solve our design and optimization problems? And this is not trivial, because there might be boundary conditions like organizational constraints, which drive the technical implementations. Sometimes it's the way around. So there are many factors which play a role in the selection of the strategies. Upstream the developments, indeed, you have the selection of the requirements and of the right design strategies. So we're designing for manufacturing, for performance, would be definitely a different process there. Downstream, there is another challenge, which is once we could produce a number of solutions, which ones we're going to choose. And nowadays we have an overflow of information, so we have big data analysis, trend identifications, which might support the selection of the right products. Now, I was thinking when I started working on that everything could have gone pretty straight from left to right, but I realized quickly that it was pretty different in the world. So a new capability suddenly was necessary to assess the different effects. This typically leads to a rethinking of the formulation of the design strategies of the design process, because maybe another partner is providing that capabilities, and you will need to think about the different strategies to execute the design and development process. There would be some updates in the implementations of the technical solutions as well, which is time consuming, if you need to do it several times. And then eventually someone decides to change the requirements or change the architecture of the entire systems, and you need to do everything again. So it's a pretty much very iterative process to move from one step to the other. And then what we observed in the past, of course, of the previous experiences, is that between 60 to 80% of the time is spent in MDO applications to deploy systems which could actually be used. So you use most of the time in the setting up activities and very short time in making use of the system that you assembled. And this is kind of one of the bottlenecks in why MDO is not really applied extensively in large-scale product yet. So there is a lack of agilities. Starting from this lack of agilities, we started thinking, what can we do? How can we improve? And this is a little bit ambitious of the AGILE projects. So to deploy the next generation of MDO, which according to us should compress the design and optimization times, the setup of the deployment and the deployment systems until 40% with respect to the state of the art, by enabling collaborative design and optimizations. So we start to look at all the phases of aircraft design and optimization process and try to deploy and develop solutions, technical solutions, which could accelerate the setup of a large-scale collaborative design systems, support the operation of the system, supporting the people. You mentioned that skills are necessary, so that people need to be involved inside the design process and supported by the technologies which is available, and indeed making use of efficient optimization techniques. And to prove all the technologies developed during the project, we decided to challenge the consortium by designing and applying the system deployed on different configurations, because we think it would be pretty different if you design boxing with respect to a UAV, with respect to random bodies, very different technologies which need to be integrated. So that was our ambition at the beginning of the project. And we start to look at what are the ingredients which will enable us to achieve those targets. We identified 4 main ingredients. First one, design competences. So you need all the skills, all the simulation tools, all the knowledge in all the fields, physics, all the aspects which need to be considered within an aircraft design process. The second point is a common language. So how could we streamline the communications between all the design competence, between all the experts within a large-scale design optimization process? A common language is really necessary for that. Third point was how to manage the deployment of a large-scale design and optimization process, how to orchestrate, how to generate, how to support the development of the strategies to be used. And the fourth point indeed is knowledge. So how can we streamline, how can we share the collective knowledge which is available in the consortium in the best ways, how to transfer knowledge between different partners. So the project, I cannot show you all the technical details behind that. The main outcomes of the project was what we call the AGILE Paradigm, which is nothing else than a blueprint for collaborative MDO deployment. So it's a list of best practices and knowledge that we identified and which could support the acceleration of design and optimization process. I will only show a few elements, key elements of the AGILE Paradigm and of the methodologies behind. A key element is to recognize that people is the centric of the design process. And usually you have different types of persons involved in the design process. So we call them the participative roles. And we identified immediately we have design specialists, which are the owner of specific disciplines, content knowledge, and so on. On the other part of the spectrum, you have the architects, which is in charge of defining the metrics of the design to be produced. In between, you have an integrator, which is responsible to translate the architect demands by making use of the competence available from the specialists and generate a design and optimization strategies. And then we identified we have a different skills, which is the collaborative engineering here, which is in charge to distribute the knowledge together all these roles, which usually have greatly difficulties in collaborating and communicating to each other and to make collaborative choices and designs. And it's a little bit like in music, so I always like to present it with a music analogies, which we have composers, a performer, a director which will play an orchestra, and everything has to fit together, everything has to be harmonized within the same symphony. The second element of the AGILE Paradigm was the knowledge and how to cluster knowledge together. So we start from the foundation of the knowledge, which is typically in design competence, which includes, as was mentioned before, simulation tools and skills from experts. There are some ways you need to utilize the knowledge which is available within a project consortiums. Another layer, if you combine all the knowledge as individual bricks available within a consortium, you could deploy design and optimization systems, which typically in MDO is used to automate the calculation and simulation of different solutions points. And even more on upper level is the development process of a product, which starts very upstream with identification of requirements, definition of the stakeholder and so on. And one part of this would be definitely the automated design of engineering services for the design and optimization of the product. Now, for each of these layers, you have definitely a specific deliverable, which is the output of these layers, but especially you have specific people which work in each of these layers. Now, the, let's say, difficult part that we observe is how to propagate information between each of these layers. So, let's say, the technical challenge was how to interface the layer between each other. And I think there are two main points to be addressed here. One is standardizations indeed, and automations which can be achieved to interface the different layers. And during the projects, for each of these layers, we identified products and data schemas, definitions, we developed standards which could enable us to streamline the propagation of information between all these layers, which means if I change my scenarios in the product development, I would like to see what kind of competence I'm missing immediately and not finding out months later during the design process. Or the way around, if I plug a new technologies on the bottom, I would like to be able to automatically check if all the connections are available and what is the impact on my development product process. Last part of the, let's say, other elements of the AGILE paradigm here. If you're dealing with MDO, a lot of times you focus on the tools and on the software until you can assemble actually a design and optimization workflows for platform. But there are much more steps before this, from the definition of the design case, specifying what are the competencies available within the consortium, and this is pretty tricky part, because each partner might have their own classification and taxonomy and nomenclature, so it's not easy to streamline within a large scale consortiums, and then indeed define the right strategies and so on. And typically this is happens in different stages of the development, so you might have the same approach for a conceptual stage, for a preliminary design stage, for a detailed stage, and so on. Now what we did during the project, it was actually to come up with the formalizations. You cannot read, because I cannot read it from here, what is inside steps, but basically we generated a formalization of what you could do for each of the roles acting within the designs, what it can be done to make it faster. And then you will say, yes, it's nice on the PowerPoint blocks, but actually we did also an implementation of that. So the model was implemented within using different technical solutions here. So if I come back to the different phases that we have during a design and optimization process deployment, what we did was to develop for each of these phases specific technologies. So for each of the colorful picture that you see, it's actually developments which was done during the projects by some of the partners. And I would like to tell you all the details behind them, because I like myself to bring them. But I can only tell you there are definitions and ontologies of product models, process models, knowledge-based platform which can automate the formulation of the design strategies, simulation platform which would automate the translation of the design strategies into an executable design workflows, and even post-processing solution, data analysis, visualization, and so on. So all the ingredients which you will need to be flexible, to jump from one phase to the other and next, we develop a set of technologies, implement them, and test them. And I only want to show a few of them, which I think they were kind of key enablers during the projects. One has to do with the cross-organizational. So we had different partners sitting in different countries, different companies with different acting networks. Some which is kind of challenges to not underestimate if you need to connect different companies and different networks locally. One of the challenges here, one of the first key enabler was to speak in the same language. So in this case, we choose a solution, we choose a standard, which was in this case CPAC standard. I don't go in the details. It's just a central model definitions in which all the partners could interface and produce from the single source of or a single description, produce their own disciplinary models or their own analysis models from that. So what you see here is just an example of different models produced from different partners, starting from the same descriptions of the product itself. And there were different challenges here because although you might have standards and you could speak the same language and use the right syntax, sometimes the interpretations or the semantics is still different. So we need to apply some way to capture the semantic properly and to control that. As soon as we have the capabilities which could speak to each other, of course, we start to deploy the silent optimization processes. So in the first phase of the project, we had 15 months to design one aircraft from scratch. So we received some requirements from one of the industrial partners and deployed the design and optimization workflows. This is just a representation of the visual representation of the kind of workflows we have, covering all the main disciplines and aspects which usually you face in aircraft designs, coupling different models between each other. I just want to point out a couple of let's say achievements here is that each of the capabilities was hosted in a different companies. So they were not all integrated into a single system, but it was what Bjorn was mentioning before, they were distributed to different companies. The process was fully automated in terms of defining the requirements and build the solutions. And we could go from definition of the requirements until a model which was good enough to be tested into flight dynamic simulator. So it was pretty complex with many tools inside and simulations. One part that I want to show you, which is a bit more technical, is just an example of what you see here of what is an implementation of a design and optimization workflows. We kept it very small because we won't fit in the slides otherwise. But basically the main message is that for each box, it's a service which was offered by a partner. And when I talk from a service, it's typically an engineering service, which could be a simulation capabilities offered by a partner within a larger scale product. Typically, these services might be sub-processes, which could be complex, it could be a very simple one, it could just be a number given by an expert, but all this information they need to be integrated and merged within the same design and optimization process. Another aspect was to retain interoperabilities between processes which are legacy processes of companies. So many partners and sub-processes available, they don't want to change it, but they were willing to plug them as it is within the bigger systems. And this produced, I'm telling you this story because we had to develop a number of technologies to enable the transfer of data between the different companies, filter the relative information that you're allowed to transfer, respect to the ones that you should not transfer, and so on. Different aspects where different enabler of agility is in the automation of the optimization process. So as soon as we had a workflows and design optimization workflows distributed between the entire consortium, so with 19 partners engaged, we start to play different design strategies. So the question we were asking to ourselves, which design strategies should we apply? If you are an MDO specialist, you will know what is an MDO architecture. Basically, it's just strategies to resolve problems. You might have a definition or a formalization of your strategies, and what we did was to develop a standard and models to save this formalization process. This helped to, in second steps, in which the question is, in which another aspect is that what you see here is a much more realistic design process. And what you see, or you cannot see, but I will tell you, is that the number of parameters exchanged between partners can go in the order of thousands. So we have thousands of numbers, thousands of elements linking each other, let's say connecting different capabilities in different organizations. And it's very easy to lose track of these numbers, and to have misconnections. So using standardization and automation, we're capable to guarantee the consistencies of our design and optimization problems without spending extra effort in, let's say, finding out errors later on during the design. An important aspect in collaborations when you're working with people which is distributed in different companies is to gather all together and to talk to them. So we'll use telcos, of course, but what it was necessary was to develop some solutions in which I could ask concurrently to the specialists sitting in a different companies, please let's look now together to our design process, let's look at the details. So we developed some solutions. It was web-based, accessible in this case by all the design teams. We could inject from the overall process down to the parameters which were exchanged between the different capabilities. So zooming in to very high level of details for the specialist, zooming out for the integrator, zooming even one level out for the architect. So having this kind of flexibilities to inspect and validate that all the process is correctly assembled within a large consortium was a key development to increase the flexibilities during the optimization part. This is just an example for you to show you what kind of solutions were developed. The second phase is in the first phase, we actually had 15 months for one aircraft. In the second phase of the project, within 12 months, we designed still one aircraft, but with 5 different scenarios. I'm not going to tell you now the scenarios, just to give you feelings of what kind of problems we're addressing during the project here. So we start again from the requirements, have an aircraft design and optimization process, went in the classic cases of MDO, which are multi-level, multi-fidelities, multi-scales, so in which every partner were doing very detailed design sometimes, and feeding back these information to the overall aircraft designer. But then we started investigating even other kind of scenarios. An interesting one was to address the scenarios in which we have a main OEM and a main tier 1 suppliers, both with 2 fully independent ecosystems to design and optimize their own products, in this case, the airframes and the rudder. And still these 2 ecosystems should need to concurrently work each other to produce a better optimization, or in this case, the profit for both of them. An even more complex case was for the propulsion systems, in which in this case, the optimization was run to have engines, a propulsion system, which could serve, for instance, different aircraft, family of aircraft that you have. So the last scenarios was indeed changing the degrees of electrifications for the onboard systems of our aircraft. This is very, very big change because it's very highly interconnected. Any change that you do on the onboard system will definitely be propagated to the engines, to the other disciplines, and vice versa. It was also highly sensitive because it has big impact on the cost and performance of the final aircraft that was designed. So we start to play all the type of scenarios to challenge the system, to challenge the consortium, to see where the information could be, where the system could be enhanced. Finally, we moved to a third phase of the project, in which within 15 months, again, available, in this case, we designed 6 aircraft instead of 1. So, first phase, we had 1 aircraft in 15 months. Third last phase, we had 6 aircraft at the same time with the same resources of people available there. And this was actually achieved via the flexibilities of the system and technologies which were developed during the project itself. Now, just showing some of the models which were produced during the design and optimization process for each of these concepts. There were different variants for each of them, different kind of analysis, but especially different process, which was assembly for each of the products. Processes for a UAV would be much different than for a process for a turboprop. We could actually streamline the, let's say, the deployment of processes and implementations for each of these aircraft. And just to have a feeling about kind of analysis, again, they were the most, let's say, all the analysis that you would consider within an aircraft design and optimization. Problems, from flight dynamics to aerodynamics, structure, so on, cost, environment. So coming to a conclusion very quickly here, we developed a number of solutions which will actually accelerate the deployment of the design and optimization processes. It was a large-scale, several large-scale MDO scenarios were deployed within the consortium with the 19 partners, with hundreds of people working at the same times. We delivered two main outcomes from this project. First, all the aircraft that we designed, we made a database for that available for further research in the communities. Some of them are already exploited in further European projects. Second achievement, the second outcome of deliverable was the agile technologies. So we made many of the technologies that we've seen here in the presentations available as open source to the wider communities. Some prototypes of these technologies are already implemented within other projects as well. As well, you get the methodology, so the AGILE Paradigm as a blueprint of knowledge on how to deploy collaborative MDO solutions available as well. And to test that it was actually usable to externals, we decided to check one of the communities that we like most, which is the academic communities. So we deploy and deliver packages to a number of organizations outside the consortium, is located more or less on all the sides of the world, and give them in a challenge. So we had what we call the challenge activities. We had 3 teams, international, which basically did the same exercise that we had within the projects. Each of the participants had a set of competence available, a portfolio of simulation competence in this case. We give them a challenge, develop an aircraft design process, and they managed to implement via the other technologies different level of solution. Some teams were more successful than others. We don't say that it was easy, but it was very impressive what the student teams could achieve by themselves by releasing them the technologies. So this was for us one of the key. We think that for innovation actually you should go via education as well. And somehow the lecture of today is dedicated to Casimiro, Montenegro, which I learned yesterday during the opening ceremony, which was a founder of different research and educational institutions. So we think it was fitting within our spirit, the agile spirits, to show the technologies should have a direct impact from research to education. And with this, I would like to conclude a little bit with the videos that we assembled. It's just a number of screenshots and clips taken during the project, but also in activities done outside the project. And just to give you a feelings on the agile experience, on how it was working within the agile consortium. In this case, we were doing the workshops done in the different communities, in which we had a similar setup of the consortium itself, different persons engaged from different organizations engaged in different research. We tried to streamline them together. In the project, we had the systems developed, so we could not meet each other in the real world, so we were using a virtual environment to replicate a little bit the same feelings. So defining all the discussion via digital systems, like if you would be around tables. And indeed, different configuration. Actually, before we had different configurations designed during the project itself, different level of details and fidelities. And so on. Maybe I can call Filho already to join us here. Yeah. So you will just see further some example of technologies, discussions. This was a little bit the feelings that we try to digitalize for the next generation MDO. So all these kind of techniques that we will use real meetings, we try to make them digital, available with the projects to streamline again design and optimization processes. And it's just experience of the simulation which were coming out of the collaborative design studies, which were from flight dynamics and others. Keeping them in the loop is still one of the main activities which we try to have within the projects. And that's really all for the overview of the technical activities. I guess credits of what I showed actually is not, it's big efforts. There are 19 partners, 100 persons. I try to put all the names there of people which develop some technologies. But the credits goes all to the teams. A big part of the team is actually even up here, sitting between the different roles.
Okay, great. Well, thank you very much for a very thorough presentation of the AGILE program. The content of that project is, of course, very valuable and relevant. And the proof of the pudding, of course, is to manage such a large concurrent program. So before we go to the more official part of the award, perhaps it's a good idea to invite the present project members to the stage. And hopefully not all the 110 people are here, because then we have two little rooms. So would you call out, please? Please, all the AGILE project team members, leaders, whatever. So we are complete, hopefully. Yes, there's more room here. So now the official part. Like I said, it's one of the awards of ICAS for innovation in aeronautics. And I just read that just for completeness. Its purpose is to honor persons of distinction who have an exceptional record in fostering international cooperation between scientists by their personal participation and involvement in aeronautics. And the recipient, of course, we all know that by now, is the AGILE Project Consortium. And its citation is, and again I read it out loud because it's important, in recognition of aeronautics, innovations and accomplishments in advancing the next generation of collaborative multidisciplinary design and optimization processes in a truly international collaboration. Well done, and Bodo. And first, there is the official medal, and what I've told from ICAS is pure gold, so be careful. Congratulations. Thank you very much. Well done, and also for the complete team, of course. Secondly, an official award signed by the president of ICAS, Dr. Susan New. Again, thank you very much.
That's for you.
Want to say something?
I think I talked a lot during the lecture. I just want to thank, of course, the ICAS for this award. I think we're very honored to receive this award for us. And of course, most of my thanks is to the excellent teams that I had the pleasure to work together for the last 3 years. So thank you very much.
Okay, great, ladies and gentlemen. Thank you very much for attending this awards session. This concludes the awards session, and I wish you a very fruitful continuation of this day. Thank you very much.